ತತ್ವ ಬದಲಾವಣೆಯ ಕ್ಲೈಮ್ಯಾಕ್ಸ್ ಕೊಡ್ತಾರೆ ನಡೀತಾ ಇರುವಂತಹ ಸಾಧನಾ ಸಮಾರಂಭ ಇದು. ಸರ್ಕಾರದ ಸಾಧನೆ ಕುರಿತಂತಹ ಈ ಪುಸ್ತಕವನ್ನ ಸೇಮ್ ಯಡಿಯೂರಪ್ಪ ಬಿಡುಗಡೆ
Good morning, students. Now, can you hear my voice? Good morning. Can you hear me? Yes, fine. Okay, thank you. Now, this screen is also visible, right? Where 27th question I have written, I pasted. So, yes. Okay. So, I think everything is fine now. Let's get on with the class. Okay. So, let's continue from where we left in last class. Let's have a look at question number 27. Limit extends to 0 sine 3x tan 4x divided by x into sine 5x. Okay. So in this we have sine 3x, right? I will write like this: sine 3x divided by 3x into 3x into tan 4x is there. There I will divide by 4x and then to compensate it, I'll multiply by 4x. Whole divided by x is there, keep that x as it is. Sine 5x is there. When you have sine 5x in the numerator, you would prefer 5x in the denominator. So multiply and divide by 5x. Okay. So now as extends to 0, the sine 3x by 3x, that will be equal to 1. Tan 4x by 4x, this is also equal to 1. Similarly, sine 5x by 5x, when x approaches 0, this will also become 1. Then this x gets cancelled. This x gets cancelled. What is remaining? 3 into 4, 12 divided by 5. That's the answer. 12 by 5 is the correct answer. Okay. This is the actual method. Now you need not stick to this method. I'll give you one formula. Say if you have limit extends to 0, sin mx tan nx tan nx divided by px into tan qx, or tan or sine or any algebraic function, any linear function, it's okay. So either x, 2x, 3x, okay, etc. So if it is of this kind, directly you can write the answer as mn divided by pq. That would be the answer. Okay, mn by pq. Okay. So then here, by using that formula, here we have 3, 4. Here coefficient of x is 1. X can be written as 1 into x. Here 5. So the answer would be 3 into 4 divided by 1 into 5. Answer is 12 by 5. Okay. Right. So in this way, we get the answer quickly. Now here Vinith is asking, sir, it is in the form 0 by 0. Why can't we use L'Hospital's rule? Yes, we can use L'Hospital's rule, but here it will be somewhat lengthy. The reason why we use L'Hospital's rule or any other rule, any other formula, our intention is to get the answer quickly and of course correctly. That is also important. When it comes to PU exams, in PUC, you will have plenty of time. So you'll have around total of 50 questions. In that also you have several choices there. So to answer them, you have 3 hours or 3 hours, 15 minutes time. Whereas when it comes to CET exam, these are all CET level problems, which I'm discussing now. When it comes to CET, there you will have to answer 60 questions in only 70 minutes. There you need to know how quickly I can get the answer. Okay. So now here for this problem, if you use L'Hospital's rule, what happens? I'll explain you. And then you will get to know why did I not use L'Hospital's rule for this problem. Okay. So knowing that rule is one thing, and knowing when to apply that rule is the most important thing. Okay. So now coming to this problem. If you want to use L'Hospital's rule, as it is of the form 0 by 0. So if you use L'Hospital's rule, what happens? Limit extends to 0, sine 3x into derivative of tan 4x, that is cos 4x, derivative of tan 4x is secant square 4x into 4, plus tan 4x into derivative of sine 3x, that is cos 3x into 3, divided by x into cos 5x into 5, plus sine 5x into 1. This is what you are going to get. Now, if you apply the limit, still you are going to get 0 by 0 only. Again, if I use L'Hospital's rule, it will be very complicated, right? You will still get the answer, but you need a lot of time and many steps. Therefore, for this problem, directly solving in this way will give you the answer quickly. So we follow this method. Okay, is that clear, Vineet? Okay, next. Limit extends to 0, 1 minus cos x by x into log 1 plus x. This is the 28th question. Limit extends to 0, 1 minus cos x by x into log 1 plus x. Okay. So here, again, this is of the form 0 by 0. We can use L'Hospital, but not advisable. What I do is, here you have log 1 plus x, right? I'll divide by x. Since I divided by x, I have to multiply by x. So that x I'll multiply here. This x is there now. I'm writing x as x square by x. That's all. Now, as x approaches 0, log 1 plus x by x will be equal to 1. This is one formula, you know. Limit extends to 0, log 1 plus x divided by x is equal to 1. Okay. So, by using that formula, this will be equal to 1. Then this is equal to limit extends to 0, 1 minus cos x divided by x square. Okay. So directly you remember that this answer is equal to 1 by 2. Now I'll explain you from how did we get 1 by 2. But later on, if remember that this is 1 by 2. How did I get 1 by 2? Now you observe this is of the form 0 by 0. Now I'll use L'Hospital's rule. So limit extends to 0, derivative of 1 minus cos x will be sin x. Derivative of x square is 2x. Now sin x by x becomes 1. So by 2 will remain 1 by 2. So now onwards, so whenever you get limit extends to 0, 1 minus cos x by x square, immediately you write the answer as 1 by 2. So here you might be thinking, sir, for this, how can you apply the limit separately? We can. See, you know this formula, limit extends to a f of x divided by g of x, or f of x into g of x. We can apply the limit separately and multiply them. Limit extends to a f of x into limit extends to a g of x. So here 1 minus cos x by x square, I'm considering that as one function, and 1 by log 1 plus x by x as another function. So I'm applying the limit separately. While applying the limit for this, it will become 1. So, and the rest of the things will give you 1 by 2. So the answer is 1 by 2, which is the fourth option. Okay. So next question, 29th question. Okay. See here, when I'm solving these problems, you might get any doubt. Please note down those question numbers, whatever the doubts you have. You can ask at the end of the session. Okay, so I'll clarify all of your doubts at the end of the session, not in between, because it may be disturbing for many others who have understood properly. Okay, so then limit extends to 0, tan x minus sin x divided by x cube. Now you observe numerator tan x minus sin x. When I directly apply the limit, I am going to get a 0 by 0. So by looking at 0 by 0, if you think of, usually we think of L'Hospital's rule when you come across 0 by 0. Now for this particular problem, using L'Hospital's rule is not such a good idea. Why it is not such a good idea? Because look at the denominator. Once if I differentiate, I am going to get 3x square. So then when you apply the limit, still I am going to get 0 only there in the denominator. Again, if you use L'Hospital's rule, that 3x square will now become 6x after differentiating. There also it will be 0 only. And again, if you differentiate, it will become 6. So if at all you want to stick to L'Hospital's rule, you will have to use L'Hospital's rule thrice, okay, which is time consuming. So I would suggest you another method for this problem. Say using L'Hospital's rule thrice is nothing wrong in it. Okay, so it is also correct only, but it consumes more time. So I don't prefer that. Okay, so you just even look at the numerator only. Once you differentiate, you are going to get secant square x minus cos x. When I apply the limit, I am going to get 1 minus 1, 0. Okay, that's okay. So differentiating once is okay, not that difficult. Again, if I ask you to differentiate secant square x, so then you are talking about 2 into secant x into secant x tan x. Minus of cos x is there, its derivative will be plus sin x. So you will have 2 secant square x into tan x plus sin x. Again, using L'Hospital's rule means again differentiate it. Now you have to think of derivative of 2 secant square x into tan x. Its derivative will be 2 secant square x into secant square x plus 2 tan x into 2 secant x into secant x tan x. Plus there is a sin x whose derivative is cos x. Okay. So I can understand that you did not understand. Okay, so it will be very lengthy. So I don't advise L'Hospital's rule for this problem. Okay, instead what we can do now is take tan x as common from this. So if I take tan x common, here 1 will remain. Here sin x by tan x will remain, divided by x cube is there. That x cube I'll write it as x into x square. Okay, the reason why I want to write it as x into x square is because as I see one tan x here, this tan x by x, I can write this as 1 as x approaches 0. So in the next step, I need not write this term at all. Okay, then limit extends to 0. Observe here, sin x by tan x. In the denominator, there is tan x. Tan x can be written as sin x by cos x. Okay, so that sin x by cos x is there. Then sin gets cancelled. 1 by cos x, that cos x will go up. So this will become 1 minus cos x divided by x square. Okay, limit extends to 0, 1 minus cos x by x square, whose value is equal to 1 by 2. Already I told you in the previous problem. If you want, you can use L'Hospital's rule. Within one step, you'll get the answer after this. Okay, so the answer is 1 by 2, which is the second option. Okay, then 31st question. Limit extends to 0, 1 minus cos 2x degree divided by x square. Okay. Now, if I directly apply the limit, I am going to get 0 by 0. Before that, I will write like this. Cos 2x degree is there. One of them is in degrees and the other one is in radians. Then you cannot use that sin x by x formula. Okay. So I want to convert it into radians. Before that, I will use 1 minus cos theta formula. 1 minus cos theta is equal to 2 sin square theta by 2. So this will give you 2 sin square x degree divided by x square. See, if it is not in degrees, if it is in radians, then directly sin square x by x square would have been 1. So 2 into 1 answer would have been 2. But now that it is in degrees, x degree we need to convert it into radians. Okay, so x degree can be written as pi x by 180 radians, right? So this is equal to limit extends to 0, 2 into sin square pi x by 180 by x square we have. Okay, so now sin square pi x by 180 by x square. When you have sin square x in the numerator, we want x square in the denominator. Here we have sin square pi x by 180 in the denominator, in the numerator, sorry. Sin square pi x by 180 is there. So in the denominator also, I prefer pi x by 180 whole square. X square is already there. Okay. So what was missing is pi by 180 whole square. That I have divided. Therefore, I will multiply pi by 180 whole square. Okay. So we have limit extends to 0, 1 minus cos 2x degree by x square. That is equal to. So here we have sine square pi x by 180 in the numerator. Therefore, we want pi x by 180 whole square in the denominator. Now, as x approaches 0, pi x by 180 will also approach 0. So, sine square pi x by 180 divided by pi x by 180 whole square. This much will be equal to 1. So, we are left with 2 into pi by 180 whole square. 2 into pi by 180 whole square, which is the fourth option. 2 into pi by 180 whole square. That's the correct answer. Fourth option. Then, next, question number 33. Limit extends to 0. Sine pi cos square x divided by x square. Okay. Sine pi cos square x divided by x square. Now, for this problem, I cannot write, say, suppose if you have this, suppose if I write like this, sine pi cos square x by pi cos square x, pi cos square x divided by pi cos square x, this will not be equal to 1. Now, some of you may think that, sir, is it not in the form sin x by x as extends to 0? So it should be equal to 1. It need not be. It is not equal to 1. Okay, sir, one student is asking, sir, previous problem once again explain. I will explain at the end of the session, not now. Okay, so now concentrate on the present problem. Sin pi cos square x by pi cos square x is there. Here, this is not equal to 1. Why not equal to 1? Okay, so I'll come to this this question afterwards. So now just you observe this problem. Here, this is not equal to 1. Though we say limit extends to 0, sin x by x is equal to 1. Or if I have limit extends to 0, sin 4x by 4x, this is also equal to 1. There what happens is, when extends, okay, look at this. When extends to 0, this 4x will also tend to 0. So we can write that as 1. Now in this particular problem, the problem that we face is when x approaches 0, this pi into cos square x does not approach 0. Therefore, this limit is not equal to 1. I'll give you one more example. Say limit extends to 0. If I write a sin tan x by tan x, this will be equal to 1. Because now, when x approaches 0, tan x will also approach 0. So it looks like sin theta by theta, when theta tends to 0, that will be equal to 1. However, instead of tan x, suppose if you have cos x here and a cos x here, now if you say, sir, as x approaches 0, sin theta by theta, now this is not equal to 1. Why not equal to 1? Because when x approaches 0, cos x does not approach 0. Similarly here, when x approaches 0, this pi into cos square x does not approach 0. Therefore, you cannot write this as 1. Similarly, you cannot write this as 1. Okay. Because when x approaches 0, cos x, yes, cos x will approach 1. Okay, so if it is approaching 0, then only you can use this formula. Okay, so what else can we do? We can use L Hospital's rule. because you observe we have a sine of pi cos square x divided by x square. When I apply the limit as x tends to 0, why not approaches 0? Say in place of cos x, if tan x is there, yes, you can use. Say cos x as x approaches 0. As x approaches 0, cos x will tend to 1 because cos 0 is 1. In place of cos x, if tan x is there, yes, good question, then it is 1. Say you're talking about the limit x tends to 0, sin tan x divided by tan x. If this is the case, then this is equal to 1, no doubt. Because now when x approaches 0, tan x will also approach 0. Okay. Is it clear? Or let me generalize this. Limit x tends to 0, sine of any function f of x divided by f of x. This will be equal to 1 provided this will be equal to 1 provided f of x tends to 0 as x tends to 0. Okay. So if f of x is also approaching 0 when x approaches 0, then this limit can be written as 1 and not otherwise. Okay, I think I'm clear now. Is it clear, everybody? This concept, sine of f of x by f of x as x approaches 0 will be equal to 1 provided f of x should tend to 0 whenever x approaches 0. Okay, fine. Thank you. Okay. Somebody has raised your hand. Please don't raise your hand. I cannot look at everywhere. Okay. So chat box will be open. Fine. So now let's get back to this particular problem. So limit x tends to 0, y sine of pi cos square x by x square. Okay. So why did I explain that? Is because now I should not divide by pi cos square x. You should not think in that way. Okay, sine theta is there in the numerator. I want theta in the denominator. So I will divide by pi cos square x. That you should not do for this particular problem. Okay, because when x approaches 0, this pi into cos square x is not approaching 0. Okay, fine. So then now what else can I do? I can still use L'Hospital's rule. Though it is complicated, but now we don't have any other go. So I'll use L'Hospital's rule because when x approaches 0, cos square 0 is 1, but this will be pi into 1, which is pi, and sine pi is 0. Sine pi is 0, right? So in denominator anyway is 0. Okay, therefore I can use L'Hospital's rule. Derivative of this is cos pi cos square x into pi into derivative cos square x is 2 cos x into minus sin x divided by derivative x square, which is 2x. This 2 I will cancel. And now you observe this sin x by x. As x approaches 0, sin x by x can be written as 1. So what will remain now if I apply the limit? I'm going to get a cos, put x as 0, cos 0 is 1. So cos pi cos pi into pi into cos 0, which is 1, into minus 1. Okay, here minus is remaining. Divided by 2 we have cancelled, so divided by 1. What is the value of cos pi? Cos pi is equal to minus 1. Minus 1 into pi into 1 into minus 1. So that product will give you pi. So second option is the answer. Pi is the correct answer. Second option. Okay, fine. Look at 37th question now. 37th. Limit extends to 0, 1 minus cos 2x into sin 5x by sin 3x. Limit extends to 0, 1 minus cos 2x into, I'll write like this, by x square into sin 5x by sin 3x. Now as x approaches 0, sin 5x by sin 3x will become 5 by 3. How? I told you, limit x tends to 0, sin mx divided by sin nx will be equal to m by n. M, p, n, q, something like that I gave, right? So this can be written as m by n, because here you divide by mx, multiply and divide by mx, then sin mx by mx becomes 1. Here sin nx multiply and divide by n here. So sin nx by nx, that will become 1. X gets cancelled, m by n will remain. So here 5 by 3 will remain. And here, okay, that 5 by 3 I will write here outside. Limit extends to 0, 1 minus cos 2x. I'll write that as 2 sin square x. 1 minus cos 2x can be written as 2 sin square x. Here x square. I have not used L'Hospital's rule. I have used a formula from trigonometry only. 1 minus cos 2x is equal to sin square x. Now as x approaches 0, sin square x by x square will become 1. Okay. So 5 by 3 into 2. 5 by 3 into 2 will give you 10 by 3. 10 by 3, which is the first option. 10 by 3. Okay, next. Thirty-eighth question. Limit extends to 0, sin x power n divided by sin x whole power m, where m and n are natural numbers, is equal to 0. If so, it is equal to 0, they have given. Okay. So look here, we have sin x power n divided by, I will divide this by x power n. Okay. Multiply by x power n divided by sin x whole power m is there. I'll divide by x power m into x power m. Okay. So now, as x approaches 0, sin x power n by x power n becomes 1. Because when x approaches 0, x power n will also approach 0. Then sin x power m whole power m by x power m. This is nothing but sin x by x whole power m. Sin x by x whole power m. Sin x by x is 1 power. As x approaches 0, it will be 1 power m. That will also be 1. This much will become 1. Now, limit x tends to 0, what will remain? X power n divided by x power m. Okay. So x power n, x power m, they have given that this limit is equal to 0. Observe in the question itself, they have given that the value of this limit is equal to 0. When it is 0, is it 0 always, or is it 0 when m greater than n, or n greater than m, or m is equal to n? Okay. See now, if they are equal, okay, let me explore all possibilities. If I say m is equal to n, then x power m, x power n gets cancelled. Then what will remain? 1 will remain. Limit extends to 0, 1 will be equal to 1, right? So that cannot be the answer. So it is equal to 0 means the degree of the numerator must be larger. Degree of the numerator must be larger. And then only it will be equal to 0. Okay. So how it is possible? I'll take some examples. See, if I say m is, I will explore all the possibilities by giving different value for m and n. So I want to explore first option. First option, m greater than n. So let me take m is equal to 3, n is equal to 2. M is equal to 3, n is equal to 2 means limit extends to 0. We will get x square by x cube, that is equal to limit extends to 0, 1 by x. This limit does not exist. They have given 0. This is not 0. This will be 1 by 0. So it does not exist. Okay. Therefore, first option cannot be the answer. Second option, if I take m is equal to n, then say these two gets cancelled, you will get limit extends to 0, x power m by x power m. That's equal to limit extends to 0, 1. That will be equal to 1. But we want 0. So third case, what they have given, n greater than m. So let me take m is equal to 2, n is equal to 3. If that is the case, then we get the limit extends to 0, x power 3 by x square. That means limit extends to 0, x will remain. This will be equal to 0. That is what is the answer. N greater than m is the answer. Okay. So here Deepak is asking, sir, why can't we use L'Hospital's rule? No, you can, but it is a never-ending process. Because if you differentiate once, you are going to get n x power n minus 1 divided by m into x power m minus 1. Now, if you apply the limit, still you are going to get 0 by 0. Okay. So again, you have to use L'Hospital rule. N minus 1 into x power n minus 2 divided by m into m minus 1 into x power m minus 2. In that way, you go on continuing. This is a never-ending process. Okay. So using L'Hospital's rule is not a good option at this stage for this particular problem. Okay. So it is obvious that this limit will be equal to 0 when the numerator has a larger power, which means n greater than m. Third option is the correct answer. Okay. Next. Limit extends to pi by 2. Pi by 2 minus x into secant x divided by cosecant x. Okay. So in this case, I will write secant x as 1 by cos x. And I will write cosecant x as 1 by sin x. Okay. So now this will be equal to limit extends to pi by 2 minus x into the sign will go up as sin x by cos x, it will be tan x. Okay, so that is equal to, not much space available. I can write like this: limit extends to pi by 2 minus x divided by cot x. This tan x, I am taking it to new denominator, so it will become cot x. 1 by tan x is nothing but cot x. Okay. Next, when x approaches pi by 2, or I will write one more step here. Limit extends to pi by 2 minus x divided by this cot x can be written as tan pi by 2 minus x. Cos theta is equal to tan 90 minus theta. I am writing cot x as pi by tan pi by 2 minus x. Now as x approaches pi by 2 minus x will approach 0. So this is as good as limit theta tends to 0, theta divided by tan theta. Limit theta tends to 0, theta by tan theta is equal to 1. So in the same way, when x approaches pi by 2 minus x will approach 0. So this is of the form limit theta tends to 0, theta by tan theta. That is equal to 1. So limit extends to pi by 2 minus x divided by tan pi by 2 minus x is equal to 1. Did you understand this solution? How this last step, limit extends to pi by 2 minus x by tan pi by 2 minus x is equal to 1. No. Okay. Okay. So I will do like this. When x approaches pi by 2, I will make a substitution. That is, put pi by 2 minus x is equal to y. Okay. When you are introducing a new variable, you have to change the limits also. As x tends to pi by 2, y will tend to 0. In place of x, if I substitute pi by 2 here, pi by 2 minus pi by 2, y will become 0. So now, let limit x tends to pi by 2, I will replace with the limit y tends to 0. Pi by 2 minus x, it will become y. Denominator will be tan y. So limit y tends to 0, y by tan y is equal to 1. Okay. Is it clear now? I'm taking pi by 2 minus x as y. Then when x approaches pi by 2, y will tend to 0. So limit y tends to 0, y by tan y. That will be equal to 1. Okay, fine. Next. Limit extends to pi by 2 tan x. Limit extends to pi by 2 tan x. Okay, another question. Sir, in second step, can't we multiply and divide by pi by 2 minus x? Change your name first, then I will answer your question. Okay. So don't keep all these fancy names. Your name is your identity. Okay. So how good you are, your name should tell. Okay. Don't keep all these fancy names. Now, limit extends to pi by 2. Coming back to this question. Limit extends to pi by 2 tan x is. See, now, when x approaches pi by 2, what happens to tan x? Look at the graph of tan x. Let me draw the graph of tan x. Okay. This is the graph of tan x. This is 0 here, pi by 2, pi, 3 pi by 2, 2 pi, etc. We are interested in knowing what is limit extends to pi by 2 tan x. Now we observe left hand limit. When x approaches pi by 2 from left side, when x approaches pi by 2 from left side, tan x will tend to plus infinity. When x approaches pi by 2 from right side, tan x will tend to minus infinity. So here left hand limit is equal to limit x tends to pi by 2 minus tan x. That is equal to plus infinity. Then on the other hand, limit x tends to pi by 2 plus the right hand limit. Right hand limit is equal to limit x tends to pi by 2 plus tan x. X approaches pi by 2 from right side. When x approaches pi by 2 from right side, so it will tend to minus infinity. Left hand limit is plus infinity, right hand limit is minus infinity. So limit does not exist. Okay. See here, limit does not exist, not because it tends to infinity. It is because from right side, it is left side, it is tending to plus infinity. From right side, it is tending to minus infinity. Therefore, limit does not exist. Okay. So, limit does not exist, which means fourth option is the correct answer. So, which is evident from this graph also. When x approaches pi by 2 from left side, tan x will go up to infinity. And when x approaches pi by 2 from left right side, tan x will go down till minus infinity. Okay. Say left hand limit means up to pi by 2, which is less than pi by 2. There it is first quadrant, so positive. And for right hand limit, you are talking about the second quadrant. So there tan x is negative, hence it is tending to minus infinity. Okay. Next question, 41st question. Okay, so here is another doubt, sir. They have asked only at x equal to pi by 2. Yeah, at x equal to pi by 2 means when x is tending to pi by 2 means you don't directly substitute x equal to pi by 2. You're talking about x is tending to pi by 2 from left side and from right side. From left side means you're talking about first quadrant. From right side means you're talking about second quadrant. So it goes to plus infinity and minus infinity. So the graph of tan x you have learned already in first place. This is the graph of tan x. At a 0, it is 0. Okay, so then it will be like this. You just observe tan 0 is 0, tan pi by 4 is 1, tan pi by 3 is root 3, tan pi by 2 it tends to infinity. Then in the second quadrant it is negative from again pi to 3 pi by 2, third quadrant it is positive. At 3 pi by 2 again it tends to plus infinity, so positive from left side. Then from right side it will tend to minus infinity. Okay, then in the fourth quadrant it is negative. The domain is a set of all reals except the odd multiples of pi by 2. And the range is set of all real numbers, minus infinity to plus. Okay, next 41st question. Limit extends to 0, sine inverse x minus tan inverse x divided by x cube. So for this problem, see earlier we had one problem in terms of tan, sine and x cube in the denominator. For that problem, I had suggested not to use L'Hospital's rule. Okay. So now if I directly apply the limit, I'm going to get sine inverse 0, which is 0. Tan inverse 0 is also 0. Denominator x cube also 0. So limit extends to 0, sine inverse x minus tan inverse x divided by x cube. If I directly apply the limit, we are getting 0 by 0. So the denominator, though it contains x cube, we may have to use L'Hospital's rule twice or thrice. Okay. So, but that is the only way. We cannot write tan inverse x as sine inverse x by cos inverse x. Such a formula is not there. See, in trigonometry it is there, tan x is equal to sine x by cos x. But in inverse trigonometry, you cannot write tan inverse x as sine inverse x by cos inverse x, so it is not possible. So you cannot take any common thing out. So no further simplification is possible. Hence, we are left with only L'Hospital's rule. Okay, let us use it. Derivative of sine inverse x is 1 by root of 1 minus x square. Minus the derivative of tan inverse x is 1 by 1 plus x square, divided by the derivative of x 3x x cube, that is 3x square. Here if I apply the limit as x tends to 0, we are still getting 0 by 0 only. When I put x as 0, first term will become 1, second term is also 1. 1 minus 1, numerator is 0, denominator also 0. So use L'Hospital's rule again. Using L'Hospital's rule again, derivative of 1 by root 1 minus x square, it is of the form 1 by x. Derivative 1 by x square is 1 by x is minus 1 by x square. So derivative of this is minus 1 by 1 minus x square into the derivative of root 1 minus x square, which is 1 by 2 root of 1 minus x square into the derivative of 1 minus x square, which is minus 2x, minus the derivative of 1 by 1 plus x square. Again, you can imagine that as 1 by x. Derivative of 1 by x is minus 1 by x square. So derivative of 1 by 1 plus x square would be minus of. So minus into minus, this will become plus here. 1 by 1 plus x square whole square into the derivative of 1 plus x square, which is 2x. Okay. Denominator, derivative of 3x square is equal to 6x. Okay. So now I will take 2x as common and cancel it. I'll take 2x minus into minus plus 2x. So 2x as common and I will cancel that 2x. So then what will remain here? 1 by 2 into 1 minus x square into root of 1 minus x square plus 1 by 1 plus x square whole square whole divided by 3. I have taken 2x as common and cancelled it. 3 will remain. Okay. So now let us say if I apply the limit, what are we going to get? Put x as 0, this will be 0, 1 minus 0, 1. Here also 1 minus 0, 1, root 1 is 1. So first term will give you 1 by 2 plus second term will give you, where I put x as 0 here, we are going to get 1 divided by 3. 1 plus 1 by 2 is 3 by 2 by 3. So that is equal to 1 by 2. 1 by 2 is the correct answer. 1 by 2, which is the fourth option. Okay, is that clear? I've used L Hospital's rule twice. Okay. Then coming to this question, 43rd question. Limit extends to pi by 2 cot x minus cos x divided by pi by 2 minus x whole cube. Cot x minus cos x. Limit extends to pi by 2 cot x minus cos x divided by pi by 2 minus x whole cube. Here I will take cot x as common. Okay, I will take cot x as common. Then you will have 1 minus cos x divided by cot x divided by pi by 2 minus x whole cube. That's equal to limit extends to pi by 2. This cot x is there now. Cot x, we can write that as tan pi by 2 minus x. Cot x can be written as tan pi by 2 minus x into 1 minus, see cot x is there. I will write cot x as cos by sin. Then cos x gets cancelled. You will have 1 by sin x in the denominator. That sin x will go up. So it will become 1 minus sin x divided by, there is pi by 2 minus x whole cube. I'll write like this, pi by 2 minus x into pi by 2 minus x whole square. Okay, now as it extends to pi by 2 minus x will tend to 0. When x approaches pi by 2 minus x will tend to 0. Okay, so limit extends to pi by 2 tan pi by 2 minus x divided by pi by 2 minus x. This is as good as tan theta by theta as theta tends to 0. Now you might think x tends to pi by 2. X tends to pi by 2 is all right. When x tends to pi by 2 minus x will tend to 0. So it is of the form limit theta tends to 0 tan theta by theta. Limit theta tends to 0 tan theta by theta, that is equal to 1. So that much you leave, need not write in the next step, that is 1. Okay, then what do we get? Limit extends to pi by 2 1 minus sin x divided by pi by 2 minus x whole square. If we directly apply the limit here, sin pi by 2 is 1. 1 minus 1 0. Denominator pi by 2 minus pi by 2, that will also be 0. 0 by 0 is an indeterminate form. So I will use L Hospital's rule here. Okay, derivative of 1 minus sin x is minus cos x divided by 2 into pi by 2 minus x into minus 1. Okay, minus gets cancelled. This is equal to limit extends to pi by 2. Cos x is there now. I can write that as sin pi by 2 minus x divided by 2 into pi by 2 minus x. So this minus we have cancelled. And I have written cos x as sin pi by 2 minus x. Now again, this much sin pi by 2 minus x divided by pi by 2 minus x becomes 1. Because when x approaches pi by 2 minus x will approach 0. So it looks like sin theta by theta when theta tends to 0. Sin theta by theta when theta tends to 0 is equal to 1. So the answer is 1 by 2. 1 by 2. X tends to pi by 2. Yes, when x tends to pi by 2 minus x will tend to 0. Okay. Is that clear? 1 by 2, which means second option is the right answer. Okay. Next question. 44th question. Limit extends to 0, 3 tan x minus tan 3x divided by 2x cube. Okay. So limit extends to 0, 3 tan x minus tan 3x divided by 2x cube. If we directly apply the limit, we get 0 by 0, tan 0 is 0, denominator also 0. But it will be somewhat complicated. Let us make use of tan 3x formula. Tan 3x, for that we know the formula. So I'll make use of that. Tan 3x formula is 3 tan x minus tan cube x divided by 1 minus 3 tan square x. Right? This is the formula you have. So let us make use of this formula. Divided by 2x cubed. This is equal to limit x tends to 0. Take LCM here. 1 minus 3 tan x is LCM. This will be 3 tan x minus 9 tan cube x minus 3 tan x minus into minus plus tan cube x divided by 2x cube into 1 minus 3 tan square x. That's equal to limit extends to 0. So here 3 tan x gets cancelled. Minus 9 tan cube x plus tan cube x will give you minus 8 tan cube x divided by 2x cube into 1 minus 3 tan square x. Now as extends to 0, tan cube x divided by x cube will become 1. Tan cube x by x cube is 1. Minus 8 by 2, that is minus 4. Divided by, put x as 0, that will give you 1 minus 0. So this is equal to minus 4. Okay. Okay. Now Deepak is saying, sir, why can't we multiply and divide by x? If you multiply and divide by x, the problem that you face is 3 tan x by x into x minus tan 3x by 3x into 3x. Here divided by 2x cube. So here 3x will remain, right? So if it is product, we can do it is some part. You are going to get 1 minus 1 here, 0 minus 0. Still, it will be an indeterminate form. If it is into, we could have gone for that. If it is minus here, then using that is not advisable. Okay, have a look at this question. Limit, 47th question. Limit extends to 0 log 1 plus x minus log 1 plus ax minus log 1 plus bx divided by x. If you directly apply the limit, putting x as 0, this x as 0, you get log 1. Log 1 is 0. Here, if you put x as 0, this will also give you log 1, which is also 0. Log 1 minus log 1, 0 minus 0. Numerator is 0, denominator also 0. So I will use L'Hospital's rule. L'Hospital's rule. Derivative of log 1 plus ax is 1 by 1 plus ax into a minus the derivative of log 1 plus bx is 1 by 1 plus bx into b divided by the derivative of x, which is 1. Apply the limit as x tends to 0. That will give you a minus b. A minus b is the answer, which is the second option. A minus b. Okay. Next. 49th question. Limit extends to 0. 7 power 3x minus 5 power 4x divided by x. If you directly apply the limit, 7 power 0, that is 1, minus 5 power 0, which is also 1. 1 minus 1 is 0 divided by 0. So I will use L'Hospital's rule. So if I use L'Hospital's rule, derivative of 7 power 3x is 7 power 3x into log 7 into 3 minus the derivative of 5 power 4x is 5 power 4x into log 5 into the derivative of 4x, which is 4, divided by derivative of x, that is 1. Now apply the limit as x tends to 0. As x tends to 0, 7 power 0, that is 1. This will give you log 7 into 3. So 3 log 7 minus 4 log 5. You get 5 power 0, this is 1. So into log 5 into 4. So 4 log 5. 3 log 7 is nothing but log 7 cube minus log 5 power 4. Log m minus log n is equal to log m by n. You can write that as log 7 power 3 divided by 5 power 4. 7 cube, 7 into 7 is 49 into 7, 343 divided by 5 power 4, 25 into 5, 125 into 5, 625. Okay, so log 343 divided by 625 is the answer, okay, which is the third option. Okay. Shall I solve some more problems, or should I stop for today's class? As I say, the number of participants is decreasing like anything in the last 5 minutes. Okay, let me solve one more problem and then I leave you. Okay, so those who have the doubt can ask your doubts. Okay, afterwards, just one more. Okay. So limit extends to 0, e power tan x minus e power x divided by tan x minus x. If I directly apply the limit as x tends to 0, tan 0 is 1, e power 1 is, tan 0 is 0, e power 0 is 1, minus e power 0, that is 1, 1 minus 1, 0, numerator is 0. Denominator tan 0 minus 0, that is also becoming 0. Okay, so 0 by 0 an indeterminate form. But using L'Hospital's rule is not a good idea, because derivative of e power tan x is e power tan x into secant square x minus this will be e power x. Then when you apply the limit, still it is 0, and denominator secant square x minus 1. Secant square 0 is 1, 1 minus 1, 0. 0 is by 0 only. Okay, again using L'Hospital rule twice will be complicated. Okay, so I would like to use this formula. Limit extends to 0, e power x minus 1 by x. This is equal to 1. This formula you know. Now, I will take e power x as common from the numerator. Then what will remain? E power tan x by e power x minus 1 will remain. Okay. In the denominator, okay, denominator I will retain this as it is, tan x minus x. Okay, so No, we don't get that. Sumit, you're saying, sir, with the LS rule, we'll get the answer in only one step. We don't. Because you say, if you differentiate, limit extends to 0, e power tan x into secant square x minus e power x divided by secant square x minus 1. If you put x as 0, tan 0 is 0, e power 0, 1. Secant square 0 is 1, e power 0 is 1, 1 minus 1, numerator 0, denominator also 0. Now again, differentiating this will take more time, so I would not prefer that. Okay, so now, okay, I'll send a PDF in the group, but attend to the last question, Sneha. Limit extends to 0, e power x, e power tan x by e power x can be written as e power tan x minus x minus 1 divided by tan x minus x. Okay, so now I will write it in this way. I'll split this as two separate problems. Limit extends to 0, e power x into limit extends to 0, e power tan x minus 1 divided by tan x minus x. Okay. See, when x approaches 0, tan x minus x will also approach 0. So I can use this formula. What was that formula? Limit extends to 0, e power x minus 1 by x is equal to 1. I can use this formula. In place of x, we have tan x minus x. Here also we have tan x minus x in the denominator. So this much will be equal to 1 according to this formula. Because when x approaches 0, tan x minus x will also approach 0. So limit extends to 0, e power x, e power 0, that is 1. Here this is 1, 1 into 1 is equal to 1. So 1 is the answer, which is the first option. Okay, with this I will stop today's class. And on Saturday, I forgot to give the assignments. I'm sure that you were disappointed. But today I will not disappoint you. I will send the question numbers, whatever the problems which I have left in between. I'll send those question numbers. You solve them. That will be your assignment for today. Okay. So now those who have any doubts, please stay back in the meeting. And those who do not have any doubts can leave the meeting and have your breakfast. Okay. So Annapurna has a doubt, which is question number 25. 25. Where is 25th question? So 25th question, if you want, I have to search. 44th. Okay, let me answer them first. 40. So 25th question, better you post it in the group. I'll answer there only in our WhatsApp group. 44th question, I will answer now. 44th. Okay. Tan 3x. I'm using the formula tan 3x. 3 tan x minus tan cube x divided by 1 minus 3 tan square x. Okay. After that, I am taking LCM here. LCM is 1 minus 3 tan square x. So this numerator will be 3 tan x into 1. That will give you 3 tan x. 3 tan x into minus 3 tan square x. That is minus 9 tan cube x. Minus of 3 tan x. That is minus 3 tan x. Minus into minus tan cube x is plus tan cube x. So here this 3 tan x gets cancelled. Minus 9 tan cube x plus tan cube x will give you minus 8 tan cube x. Denominator is 2x cube into 1 minus 3 tan square x. So tan cube x by x cube is 1. So minus 8 by 2, that will give you minus 4. And here when I put x as 0, tan square x will be 0. 1 minus 0 is 1. So minus 4 by 1 is equal to minus 4. Then 38th question. Where is 38? Okay. So limit extends to 0, sin x power n by sin x whole power m. M and n are natural numbers. They have given that this limit is equal to 0. Then how m and n are related? That is the doubt here. Okay, so limit extends to 0, sin x power n is there. I will divide by x power n, divide and multiply by x power n. Then sin x power n by x power n as x approaches 0 will become 1. In the denominator, we have sin x whole power m. I have divided by x power m and therefore multiplied by x power m. So sin x whole power m by x power m, that will become 1 as x tends to 0. So now we have x power n by x power m. Now, given that this limit is equal to 0. So given that this limit is equal to 0 means, say you can cancel something, right? Or you can write this as limit extend. Okay, say if m is equal to n, both gets cancelled, we'll get the answer as 1. But we want 0 as the answer. If you want 0 as the answer, something should remain in the numerator. Say, for example, if you have limit extends to 0, x power 5 by x power 4, then x power 4 gets cancelled, x will remain. When you apply the limit, it will become 0. But if you reverse it, let us say if the numerator is x power 8, denominator is x power 10, then what happens? X power 10 gets cancelled. Here x square will remain. Then you are talking about the limit extends to 0, 1 by x square. This will tend to infinity. But we want 0 as the answer. We want 0 as the answer means numerator should have a larger power. So in the numerator, some x or x square, x cube, x power 4, something like that should remain. If that happens, then it will become 0. Okay. Otherwise, if the denominator has a larger power, then the answer will be infinity. Okay. So numerator should have larger power. That means third option is the answer. Uh, 51st question, how to solve by using L'Hospital's rule. 51. Yeah, by using L'Hospital rule. If you want L'Hospital rule only, you see, okay, look here, I'll try to answer here only. E power tan x after once if I differentiate, this is what I am going to get. E power tan x into secant square x minus e power x. Again, it is of the form 0 by 0. So now if I use L'Hospital's rule, limit extends to 0, e power tan x into derivative of secant square x is 2 secant x into secant x tan x plus secant square x into derivative of e power tan x is e power tan x into secant square x minus derivative of e power x is e power x divided by 2 secant x into tan x. Okay, this much you get. Now if I apply the limit, still you are going to get 0 by 0. Again, you use L'Hospital's rule. No, I mean, you may get the answer, but it will take a lot of time and you are wasting a lot of energy as well as time. So not advisable. Okay. Very complicated. L'Hospital's rule we use in order to get the answer quickly. Okay. So if you are getting the answer quickly, then only you should use L'Hospital's rule, not always. Then can we apply log in 49th problem? No, you cannot apply log here, not possible. Because nothing is there on LHS. 43rd question. 43rd. Okay. A limit extends to pi by 2 cot x minus cos x divided by pi by 2 minus x. Pi by 2 minus x whole cube. Now I have taken cot x as common. Then here 1 will remain. Here cos x by cot x. Okay. Then cot x, I am writing that as tan pi by 2 minus x. Cot x can be written as tan 90 minus theta. Tan pi by 2 minus x. Into 1 minus cos x by cot x is there. So it will be cos x divided by cot x can be written as cos x by sin x. So this cos x gets cancelled. This sin x will go up. So 1 minus sin x divided by pi by 2 minus x whole cube is there. Pi by 2 minus x into pi by 2 minus x whole square I have written. Now tan pi by 2 minus x divided by pi by 2 minus x. When x approaches pi by 2, this will become 1. Because if you take pi by 2 minus x is equal to theta, then as x tends to pi by 2, theta will tend to 0. So this will be limit theta tends to 0, tan theta by theta, which is equal to 1. Then we have 1 minus sin x by pi by 2 minus x whole square. I have used the L'Hospital's rule here. Derivative of 1 is 0. Derivative of sin x is cos x. So minus cos x you have. Divided by the derivative of pi by 2 minus x whole square is 2 into pi by 2 minus x into minus 1. Now as x approaches pi by 2, here this minus minus I have cancelled, and cos x I have written as sin pi by 2 minus x divided by 2 into pi by 2 minus x. So as x approaches pi by 2, sin pi by 2 minus x divided by pi by 2 minus x will become 1 by, that will be 1. So the answer is 1 by 2. Then 41st question. Limit extends to 0, sin inverse x minus tan inverse x divided by x cube. Here if we directly apply the limit, you will get a 0 by 0 because sin inverse 0 is 0, tan inverse 0 is also 0. Denominator also 0. 0 by 0 is an indeterminate form. So use L'Hospital's rule. Derivative of sin inverse x is 1 by root of 1 minus x square. Derivative of tan inverse x is 1 by 1 plus x square. Now if I apply and derivative of x cube is 3x square in the denominator. Again, if I apply the limit, I am going to get 1 minus 1 in the numerator, which is 0. Denominator will be 0. So 0 by 0, an indeterminate form. Now we have to use L'Hospital's rule again. Derivative of 1 by root 1 minus x square. It looks like 1 by x. Derivative of 1 by x is minus 1 by x square. So derivative of 1 by root of 1 minus x square would be x square minus 1 by x square. So minus 1 by square of root 1 minus x square, that will give you 1 minus x square into the derivative of root 1 minus x square. Derivative of root 1 minus x square is 1 by 2 root 1 minus x square into the derivative of 1 minus x square, which is minus 2x. Minus, now we have 1 by 1 plus x square, whose derivative is minus 1 by 1 plus x square whole square into the derivative of x square, which is 2x. Minus is already there, minus into that, minus has become plus. Now I will take 2x as common factor and cancel. I'll take 2x common and cancel. Then what will remain here? Minus into minus plus. Denominator is 1 minus x square into 2 into root 1 minus x square. 1 minus x square into 2 into root 1 minus x square. Here 2x we have cancelled. 1 by 1 plus x square whole square will remain. Here 6x is there. 2x we have taken common and cancelled. So 3 will remain in the denominator. Then put x equal to 0. Simplify, get the answer as 1 by 2. Okay. 27th. 27th. Sin 3x tan 4x by x into sin 5x. Sin 3x I'll divide by 3x into 3x. For tan 4x I'll divide by 4 into 4x. Okay. So sin 5x by 5x. Here also multiply and divide by 5x. Then as x approaches 0, sin 3x by 3x becomes 1. Tan 4x by 4x becomes 1. Sin 5x by 5x will also become 1. X gets cancelled. 3 into 4, 12. Divided by 1 into 5, 5. Which directly, by using this formula, directly you can write that as mn by pq. 31st question. Okay. 1 minus cos 2x degrees. 1 minus cos theta can be written as 2 sin square theta by 2. So 2 sin square 2x degree by 2. That means x degree. 2 sin square x degree divided by x square. Okay. Here the angle is in degrees. If it is in degrees, you cannot use this formula. You have to convert it into radians. So x degree is equal to pi x by 180 radians. So that I have used. Then sin square theta. If sin square theta is there in the numerator, you want theta square in the denominator. Denominator we have only x square. We want pi x by 180 whole square. So divide by pi x by 180 whole square and divide by pi by 180 whole square and therefore multiply by that. As x approaches 0, this much will become 1 and we are left with 2 into pi by 180 whole square. Last question. Where is the last question? Okay. So here I have taken e power x as common. Then e power tan x by e power x minus 1. Denominator as it is. So e power tan x by x can be written as e power tan x minus 1. Okay. Now I'm splitting this into two terms. You imagine this as f of x into g of x. Limit extends to a f of x into g of x can be written as limit extends to a f of x into limit extends to a g of x. Okay, so I had taken e power x separately. Now look at this. It looks like limit extends to 0 e power x minus 1 by x. Okay, in place of x we have tan x minus x here, and we have tan x minus x here. So by using this formula, this expression can be written as 1. 1 into 1 is equal to 1 is the answer. Explain 49th question. 49th question, direct, very simple question. Use L'Hospital's rule. That's all you'll get the answer. Use L'Hospital's rule once. Because directly if I apply the limit, I am going to get 1 minus 1. 7 power 0 is 1, 5 power 0 is also 1. 1 minus 1, 0. Numerator 0, denominator 0. If you use L'Hospital's rule, derivative of 7 power 3x is 7 power 3x into log 7 into 3 minus derivative of 5 power 4x is 5 power 4x into log 5 into 4 divided by the derivative of x, which is 1. Apply the limit, then just a simplification. 31st, just now I have explained. 40th question, answer does not exist. Yes, it does not exist because left hand limit is, observe, left hand limit is plus infinity, right hand limit is minus infinity. Therefore, limit does not exist. Sir, please little bit slow. Okay. Okay. Okay, students, any doubt? Okay, that's all. I think I have cleared all of your doubts. If you do have a PDF, I will send the PDF. Don't worry. Okay. Okay then. Thank you.